Hey all, I am Akash Bhagwaj, a Y16 electrical engineering graduate. A bit more about me academically. I did my pre-final and intern at Texas Instruments India as an analog design engineer. Post-graduation, I'll be joining Samsung R&D India as, as a research engineer, right? What I'll do in this video is I'll try and talk a bit about core electrical internships. What exactly is the nature of work that you do there, the selection process, the interviews, tests, and all those kind of things, right? So starting off with the nature of projects that we have, I'll give you the example of my own project. Okay, so let us try and imagine a speaker, any simple speaker, a Bluetooth speaker device that you have, or a mobile phone speaker, or anything, right? Or any physical device for that matter, right? If you have to measure the parameters of the device, you have two probable approaches with you. One is you design the device, send it for fabrication, and once the fabricated or physical device is back with you, you actually test the device for its parameters. For me, the parameters were power consumption and efficiency values, right? The contrasting approach could be, instead of testing on the physical device, once you have the CAD model of the device ready, you know the parameters of the device. Now, if you have a model or a system, something through which you can input the parameters and get as output the approximate power consumption or efficiency values. Okay, how this helps is, let's say the desired efficiency is 87%, right? And you put in the parameters, you got the efficiency of 82%. You know there's a lag of 5%, right? What you'll do is you'll naturally tweak in the parameters, you'll change the capacitances, you'll change the resistances, or maybe the DC input at the boost or something, and you'll tweak it through the 87-86% mark, right? Now once this more efficient device is known with the respective parameters, you send it to fabrication and eventually get the best probable device. The second approach seems more reliant, more feasible, more efficient, but the first one is what is actually done in the industry, right? So this is where my internship project was. So what I had to do is basically design a MATLAB model which would take in the parameters associated with the device and would predict the approximate power consumption and efficiency values, right? I was given a device whose power consumption and efficiency was physically measured, and my model had to actually emulate that particular device, right? What I needed to know about it, okay, so the construction of the device was basically a cascading of a class D audio amplifier and DC to DC boost converter. So I just had to know basic stuff about these two components. Class D amplifier is just an amplifier, nothing special, and DC to DC boost converter is something we learn in power electronics, so just basic electrical engineering stuff, and I was good enough with the project, right? So having bored you with this long description, let us come to the more important, more prominent question: how exactly do we land up these internships, right? So my experience would be pretty much limited to TI, okay, because but TI being the most prominent electrical engineering firm that comes on campus, I guess that should be fit enough, right? So for TI, be it a test, be it their on-campus interviews, be it their PPO interviews, whatever, all you need to know is just two concepts: RC circuits and op-amps. What about RC circuits? A detailed knowledge of first order RC circuits, decent enough knowledge of second order RC circuits, and well, for op amp you don't really need to know the construction of op amp, the amplifier part, or the sorry, the other components involved in that. All you need to know is just the applications part. I'm sure you've learned about the use of op amps to make integrators, adders, subtractors, differentiators, and all those devices, right? So just that application part, basic op-amp equations and all those things. Okay. So this was in terms of concepts. In terms of courses, if I say, you need to know just two things. It's E210 and ES0, right? This should actually suffice for the analog part. For the digital part, we have E370, which you can do, but by the time TI conducts its interview, you don't actually have good enough knowledge of the E370 concepts, right? For the digital part, the most you can do is just brush up the last 10 to 12 lectures of EHC21 well. You'll get the K-maps and all those kind of things. You'll be able to solve not more than 20-25% of the TI tests digital questions, right? But yeah, that is all you can do. And rest assured, even the interviewers and the test makers, they all know what you've been taught thus far. So they have that in mind, and the interview process and the whole selection process is designed accordingly, right? Yeah. So this was, you know, all I had to say about these things. I'll also add a small little hack over here. I don't know if you heard about Nagendra Krishnapura. He's a professor at IIT Madras. Okay. So just go to his homepage. You'll find a list of videos over there. You'll have about 6 to 7 videos about RC circuits, first, second order, and all other relevant stuff. You'll have 2 to 3 videos about op amps, their applications, and those things, right? Now, what these 10-12 videos in combination do is that, at least for me, any question that I was asked in a test or in an interview at TI were a direct replica of examples sir Krishnapura sir taught in his videos. Direct replica, I must say. Okay, so if you're done with your basic stuff, that is ESC201 and E210 part, and you have time, you feel you need to understand more, you need to get more of it, right? Just go to Krishnapura sir's video and you would be in a better state. So yeah, this was all I had to say about electrical engineering internships, my experience, my journey, and all. Right. If there's any other question you need to know, just ping me. Yeah. Thank you. Bye.